Let's go over how to do the check for an equation. When we solve an equation, we get an answer, our variable equal to something. How do we know if that's correct? Well, we use what we call a check to test it out. Let's try it with an example. Here we have -5 times in parentheses 7 minus 4h equals 25. This is my original equation, the equation that I've been asked to solve for h. Right here, it looks like we have something like distributive property. So let's say I went through those steps. I used my distributive property, reverse order of operations, did the opposite to both sides. I get my solution to be h equals 3. Right now, I'm not worried about the steps because I want to focus on the check. But now that I have my answer, I need to see if it's correct. Because if this was a test, I would want to know if I had the right answer. So let's move on to our check. For our check, all we do is take our original equation, and what I'm going to do is take my h equals 3, and I'll plug in my 3 in place of the h in my original equation. From here, I can rewrite my equation to be -5 times, in parentheses, 7 minus 4 times 3 equal to 25. This is my new equation. From here, I want to use the order of operations, or PEMDAS, to solve this equation. I'm not going to use the distributive property that I used to solve my equation before when I had the variable in place. I'm just going to use my order of operations. So I'll start with my parentheses. Inside my parentheses, I have subtraction and multiplication happening, but I'll start with multiplication because that's the order of operations rules of PEMDAS. So I'll start with my -4 times 3. My new equation is now -5 times, in parentheses, 7 minus 12 equals 25. From here, I still have my parentheses, so I'll do 7 minus 12. I'll come up with my new equation to be -5 times -5 equals 25. I continue step by step to get 25 equals 25. Notice how I went through each step of my check. I went through and I did the math for each part of order of operations to get my 25 equals 25. I didn't do a pretend check. I didn't just plug in 3 and leave it and say that that was correct. I went through each step to see 25 does indeed equal 25. So I can draw my smiley face. My solution was correct. That means my h equals 3 was the right answer. So I'm all done with that equation. Now that we've looked at a distributive equation problem, let's take a look at another example, right? The rules for checks apply for all equations. So here's our new example. We have -5x minus 18 plus x equals 2. This one is a combined like terms equation. So let's say I solved it, again, using reverse order of operations and the opposite to both sides. I get my solution to be x equals 5. Again, we're not worrying about the steps too much, just focused on the check for now. So for our check, we take our original equation again, but this time I'll take my x equals 5 and I'll plug it in for both spots where there's an x. I'll put my 5 in place and I'll get my new equation to be -5 times 5 minus 18 plus 5 equals 2. Here's my new equation, and I can start using my order of operations. My -5 times 5 gives me -25. Rewrite the rest of my equation, and I can go step by step of PEMDAS. This is now addition or subtraction, whichever comes first from left to right. So -25 minus 18 will give me my -43 plus 5 equals 2. I continue step by step, and I end up with -38 equals 2. That's not right. -38 does not equal 2. That also means the last 3 steps that we did where we plugged in 5 were also incorrect. My check didn't actually check out, so I don't get my smiley face. My solution must have been incorrect. Something was wrong. This should be your signal if your check doesn't work, that your solution was wrong, and you need to go back and check your work. Check the steps that you took, right? Maybe I missed a negative sign. Maybe I've added instead of subtracted. Maybe I multiplied instead of divided. Right now, it doesn't matter because I don't have my steps in front of me, but this is my signal in my check that something's wrong. So my answer is not actually x equals 5. This is how we can use the check to solve our our equations and make sure that our answers when we solve our equations are correct.